Hi guys, welcome back to my channel. So I hope you all are doing well. In this video, we are going to solve the problem, can I will? And the problem is very much interesting because it includes three concepts, Bitmask, game theory, and dynamic programming. And all these concepts are so much interesting and they are not too easy to grasp. So these kind of problems are usually seen in computer programming, not in typical DSA. But if we are tackling these, then we should definitely solve these kind of problems. So I suggest you to try this problem on your own. So let me first explain this problem. After that, you should go and try this problem on your own to solve it. So the problem is saying that we are having a game that is 100 game, and we have two players P1 and P2, and we have to return if the player 1 can win or not. So let's discuss the rules of this game. You are given two integers. The first one is max choosable integer, and the second one is desired total. So what are these integers? At each chance, every chance you can choose any integer between 1 to max choosable integer. Is from 0 to max choosable integer, and you have to reach to desired total. If any of the player reaches to desired total, then he will win. So we have to also assume that both players are playing optimally. So let's discuss one test case so that you will get its idea. So we have the maximum choosable integer is 10 here, and the desired total is 11. So the player 1 will start the game, and if he chooses any of the number, like 2, 3, anything, then the second player will choose, like the first one if chooses 2, the second one will choose 9. So he will reach the desired total. So he will win the match. If the first one chooses 1, then the second one will choose 10. Then he will also reach the target. If the first one chooses 9 and the second one chooses 2, then also second one wins. So there is no way there is no way so that the player 1 can win the match. So we will return false here. And here on the second test case, the maximum choosable integer is 10 and the desired total is 0. So the desired total is 0. So if player 1 doesn't chooses any integer or chooses 0 in his chance, then he will reach the target. And then we can return true because player 1 can win the match. And so I hope you guys tried this question on your own. So let's move forward and see how to approach these kind of problems. So what we can do, at each chance, we have options to choose the integers between 0 to max choosable integer. We can select any number between 0 to max choosable integer. And it is also mentioned in the problem that if we choose an integer, then we can't choose it again. So we can use a number only once. Now let's suppose the solve function will return true or false for a chance if the player can win the game or not. So we will define a function solve, which will return true if the player which is currently playing wins the game, or if he doesn't win the game, then it will return false. So what are the possibilities at each chance? So at each chance we can select any integer from 0 to max choosable integer. So we will run simply a for loop for that at each chance. So what we will do, if we can choose that integer, if we can choose I, and after choosing that integer, if the opponent loses the game, then we will return true. And we will try this for every I. That is, if suppose I select 0 and I don't win, then I will try by selecting 1. I will try by selecting 2, then selecting 3, then selecting 4. So I will try each possibilities, and if anywhere I win the game, then I will return true. Otherwise, finally I will return false after this for loop. But now there is a problem that how we will keep track of the new integers which has already chosen. So for that we can use Bitmask kind of thing. So if you are not familiar with Bitmask, it will be a little bit tricky for you, but I will try my best to let you understand the concept. Because we need to solve this problem. So let's suppose we have initial a number k and it will be called Bitmask, and we use this number to check which numbers are available to use and which numbers are already chosen. So we will use this k only to detect that. So what we are going to do, we just write binary representation of k, and if it is 0, then it will be 0, 0, 0, 0, 0. And each bit of k denotes an integer that we can choose. If the bit of k is 0, it means we can use that integer. It is not already chosen. If any bit is 1, it means that number of integer is already chosen and we can't choose it anymore. So from rightmost, we can see that the 0th bit indicates the integer 0. The first bit indicates the integer 1. So suppose we have chosen a 6th bit, the integer 6. So what we are going to do, we are going to set this bit to 1, and we can use this formula to set a bit. I believe that you will be familiar with these kind of bit manipulation formulas. So this is all about bit masking, and we are going to use this in our code. It will be more clear to you if you see the code. So let's move forward and see the code for this problem. So that it will be more clear to you. So this is the code for C++ code for this problem. It starts from here. If the desired total is 0, it means we don't. It's kind of a base case. So if the desired total is 0, means we don't need to choose anything. Then player 1 will easily win the match. So we are returning true here because the player 1 is already won. Now we are calculating total. That this total means that how much maximum sum we can create using that max choosable integer. Up to how much we can total we can get. So how we can calculate that? Suppose there is an integer n, and we want to find the sum of all natural numbers from up till n. So how we can find that? We can use a formula n into n plus 1 by 2. So we are using that simply maximum choosable integer into maximum choosable integer plus 1 by 2. So we have calculated the total that we can make with this maximum choosable integer. So if that total is less than desired total, then we can't make it equal to our desired total by using any integer. So we can't get a desired total anyhow. So we are going to return 0 because in that case also player 1 is not going to win the match. If total is equals to desired total, then we are returning maximum choosable integer is odd. If it is odd, then we can the player 1 will win the match, otherwise it will lose. And how we can check this? Just see this case. If the maximum choosable integer is even, then any of the players will end up at 2. This the second player will use his last chance to finish the game. And if he finishes the game, the player 1 will lose. And if it was 11, then the player 1 will finish the game. So the player 1 will win the game. That's why I am returning here. If the total is equals to desired total, then we are returning the maximum choosable integer modulo 2. Means if it is odd, then it will return true. If it is even, then it will return false. Now we have a DFS function which is taking two numbers, maximum choosable integer and desired total. And we are passing here the Bitmask k that I already told you about k. So what we are returning in DFS, if the t is 0, means desired total is less than or equals to 0, then we are simply returning 0, that no one will win the match. Now what happens if let's ignore this line for a few seconds. We are running a for loop that I told you that at each chance we have possibilities to choose the integers between 0 to m. So we are checking if that bit is set or not. So how we can check on the bit mask, like if k and we are doing AND operation. If one left shift I, if the ith bit is not set, means we can use that bit. And by using that bit, what we are doing, we are if that we can use that bit, then we are running that function again, DFS function, since we are playing the game again with by setting that bit. And if the next player will lose, means if it is not DFS is indicating that it returned false. So if the second player here return false, means he loses the game. And if he loses the game, that means the player 1 will win the game. So we are returning 1 here. And for every chance, if we don't get any of if we don't satisfy this if condition, then we will return here 0, that player 1 cannot win the match. So this is how you can write this code. And this DP is nothing but we are doing memoization. So we have a DP array, and if that is not equals to -1, we are just returning DP of k. And I believe that you will be familiar with memoization technique, so it won't be so tough for you. I hope you guys understood this problem well. See you in the next video. Bye bye.